Okay, welcome back to McNab Chemistry. Today we're going to continue our understanding of the organic chemistry language. Okay, first of all then, we're going to have a look at homologous series. Okay, so a homologous series is a family of molecules which all contain the same functional group. Okay, and they are all represented by the same general formula. They have successive molecules increase in size by a CH2 group. Okay. They have similar chemical properties, and that word similar is very, very important. Okay, because they've got the same functional group, then they tend to carry out the same chemical reactions. Okay, so they have similar chemical properties, and then they show a trend in physical properties, and that word trend is very important because as our carbon chain length gets longer, then physical properties such as melting point and boiling point change as the strength of the intermolecular forces increase. Okay. Right, okay, so let's have a look to see how organic molecules are built up. Okay, simply then, they are made from an alkyl group and a functional group covalently bonded together. Okay, so this is actually really very, very simple. Okay, so there we go. What are my alkyl groups? Okay, well, the general formula of an alkyl group is CnH2n plus 1. Okay, so let's take methyl for example. That's got one carbon, so one carbon, C1, H, 2 times 1 is 2, plus 1 is 3, so it's CH3, methyl group CH3. Okay, and here it would be that methyl group would be attached to a functional group. Okay, but the alkyl group is actually just the methyl part. Okay, our next alkyl group in the series then is the ethyl group, so C2H5, C2H5. Then we go to propyl, C3H7. Okay, butyl, C4H9. Pentyl, C5H11. Hexyl, C6H13. Heptyl, C7H15, and then octyl, C8H17. Okay, and as you can see, when we're building up an organic molecule, these alkyl groups are all attached to a functional group. Okay, so let's go through some of the molecules that we looked at in the previous video when naming compounds. So first of all, let's have a look at haloalkanes. Okay, this is when an alkyl group is attached to a halogen, haloalkanes. Okay, so let's take this one first of all. We've got an alkyl group here that's attached to a chlorine atom. Okay, so that's my methyl group. The Cl is my functional group. Okay, so the Cl determines the chemistry of this molecule. Okay, the chemical reactions. And that's called chloromethane because it's one carbon, meth, and it's attached to a chlorine, chloromethane. My alkyl group here is meth-eth, so it's ethyl, attached to a chlorine functional group, so it's chloroethane. Now let's have a look at amines. Okay, functional group of amines is NH2, so RNH2, wasn't it? R was the alkyl group, RNH2. There's my alkyl group, there's my NH2 group, that's my functional group, that's my alkyl group. Got one carbon, so it's called methylamine. Okay, this one here, meth-eth, remember, count up the number of carbons away from the functional group, so there's my functional group, meth-eth, ethylamine. Okay, let's have a look at alcohols now. So whenever I'm looking at an organic molecule, I'm thinking, right, where's my functional group? Where's my alkyl group? Okay, functional group OH, alkyl group CH3. So alkyl group CH3, so it's going to be meth, and it's methanol. Okay, this one meth-eth, ethanol, ethanol, ethan alcohol, ethanol. Okay, now let's have a look at carboxylic acids. So general formula RCOOH. Okay. Or I should say that's my functional group really. RCOOH. COOH is a functional group. Okay, methanoic acid, so COOH with an H attached to that carbon there, ethanoic acid, meth, eth. Remember, there's my functional group. Number of carbons 1, 2, count away from your functional group, but in this case the carbon in the functional group is counted as a carbon in the chain. So meth, eth, that's ethanoic acid. Okay, now we'll have a look at aldehydes, represented by alkyl group and then the CHO group, which is your functional group. Okay, so meth, that's methanaldehyde, methanal. Meth, eth, meth, eth, ethanal, ethanaldehyde, eth and al. Okay, meth, eth, prop, propanal. Okay, now let's have a look at ketones. Okay, R1COR2. Okay, so here we go, meth, eth, prop, propanone. Okay, R1 is this methyl. Got a methyl as R2, carbonyl group in between the two alkyl groups. So you can always identify a ketone because you have an alkyl group on either side of the carbonyl group. The carbonyl group, remember, is a C double bond O group. Okay, so this meth, eth, prop, bute, but that's my longest carbon chain, so that's butanone. Okay, nitriles are always a good one to remember, because again the carbon of the functional group is included in your carbon chain length. Okay, so we can represent nitriles by RCN. Okay, CN is your functional group, okay, of the nitrile. So meth, eth, that's ethane nitrile. Meth, eth, prop is propane nitrile. So in conclusion then, each of these functional groups, when attached to an alkyl group, forms a family of compounds known as a homologous series. Okay. Finally then, let's have a little look back at the homologous series of alkanes. Okay, so the first alkane in our group is methane, CH4. Then the second one is ethane, C2H6. The general formula for an alkane is CnH2n plus 2. So if I have one carbon, N is 1. C1, H2 times 1 is 2 plus 2. So CH4. And that would be methane. As you can see, as we go down our group, the chain length increases by as CH2. Okay, so what's the difference between the molecular formula of ethane compared to methane? Well, ethane has a CH2 more than methane. Okay, all alkanes have similar chemical properties, and they show a trend in physical properties, because as the chain length gets longer as we go down the group, then the strength of the intermolecular force increases, so it changes our physical properties, but there's a definite trend in that. Okay, let's have a look at the homologous series of alkenes. Okay, remember alkenes are represented by a carbon-carbon double bond. General formula is CnH2n. Okay, so ethene, CnH2n, C2H4, propene, C3H6. Okay, and then finally, let's have a look at the homologous series of alcohols. Okay, and let's just think about what the difference is between the structure of an alcohol compared to the structure of an alkane. Okay, right, well, if we look at them, if we think back to the beginning of the video, I said that organic molecules are made when alkyl groups are attached to functional groups. Okay, when the hydrogen of an alkane is substituted by a functional group. So this is exactly what happens here with alcohols. Okay, one of the hydrogens is substituted with the OH functional group. One of the hydrogens, methane, CH4, methanol, CH3OH. Okay, so one of the H's has been substituted by an OH. Okay, so therefore we can come to this general formula, can't we? The general formula for the alkane was CnH2n plus 2. Okay, but we've lost one of these hydrogens now because we've substituted it with a functional group. So the general formula for your alcohol is CnH2n plus 1 OH. Okay, it's plus 1. That's one of the hydrogens. The second hydrogen that we had has been substituted by the OH group, so we write the OH there Okay, so the general formula for an alcohol is CnH2n plus 1 OH. Okay, thank you for watching. I hope that's been helpful. Don't forget to like and subscribe and click on our bell notification to stay fully updated.